On May 18th, 2026, something the size of a basketball court crossed the orbit of the moon. It was moving at 15 kilometers per second, fast enough to go from New York to London in under 5 minutes. And for a brief moment, no one knew exactly how close it would come. This is the story of asteroid 2026 JH2, the one that almost wasn't a story at all. 10 days earlier, a telescope in the Arizona desert blinked. A faint dot of light moved against the fixed stars. That dot was 2026 JH2, and it was already heading straight for Earth's neighborhood. In astronomy, distance is measured in lies. We say close pass when an object misses us by 100,000 kilometers. We say safe when a rock the size of a building sails past at 15 times the speed of a rifle bullet. But on that Monday in May, the numbers started to get uncomfortable. At its closest approach, 2026 JH2 would come within 90,000 kilometers of Earth. That is less than a quarter of the distance to the moon. For context, the moon itself is already close enough to govern our tides and pull our oceans. This asteroid was coming 3 times closer. And yet, most people never heard about it until after it had passed. Why? Because asteroids like this one don't announce themselves. They hide in the glare of the sun. They sneak up from the dark side of our planetary defenses. And sometimes, we only find them when they're already waving hello. Let's go back to May 10th, 2026. The Lemmon Survey in Arizona is one of the most important asteroid hunting facilities on Earth. Every clear night, its telescopes scan the same patches of sky, looking for anything that moves. On that night, an astronomer named David Rankin was reviewing automatic detections. A faint streak appeared in 4 consecutive images. That streak was 2026 JH2. At the time, its brightness suggested something small. Maybe 10 meters across. Maybe less. But brightness is a liar. Some asteroids are dark as charcoal. Some are shiny as mirrors. It took 3 more days of tracking to refine the size estimate. NASA's Jet Propulsion Laboratory ran the numbers through their small body database. The result, between 16 and 35 meters wide. To visualize that, think of a standard basketball court, 30 meters from baseline to baseline. Now imagine that entire court, made of solid rock, tumbling through space at 30,000 miles per hour. That was 2026 JH2. To put it in human terms, this asteroid was roughly the same size as the Chelyabinsk meteor. You remember Chelyabinsk? February 15th, 2013. A clear winter morning in Russia. A 20-meter rock entered the atmosphere at over 18 kilometers per second. It exploded 23 kilometers above the ground. The shockwave shattered thousands of windows. Over 1,500 people were injured. No one saw it coming. Chelyabinsk arrived from the direction of the sun, where no ground-based telescope could look. 2026 JH2 was discovered 10 days before closest approach. Not years. Not months. 10 days. That is not early warning. That is barely enough time to decide whether to panic. So what will happen on May 18th, 2026? Let's track the numbers hour by hour as they are projected. At 12 o'clock Universal Time Coordinated, 2026 JH2 will still be 500,000 kilometers away. Farther than the moon. Safe for the moment. But it is accelerating toward Earth. Not because of any engine or thruster, but because of gravity. Earth's gravity pulls on everything. And the closer an asteroid gets, the harder it pulls. By 1800 hours Universal Time Coordinated, 2026 JH2 will have crossed the moon's orbit. That is the invisible line where most people start to pay attention. By 2000 hours Universal Time Coordinated, it will be inside the orbit of geostationary satellites. Those are the satellites that bring you weather forecasts, television broadcasts, and military communications. They sit at 35,000 kilometers above Earth. The asteroid will be closer than many of our own machines. At 21:23 Universal Time Coordinated, everything will change. 2026 JH2 will reach perigee, its closest point to Earth. 90,000 kilometers. To an astronomer, that is still comfortably far. To anyone who has ever looked at a diagram of the Earth-Moon system, that is terrifyingly close. Because here is the reality. Space is not empty. At 90,000 kilometers, an object can still be affected by atmospheric drag at the very fringes of Earth's exosphere. More importantly, at that distance, gravitational perturbations from Earth's uneven mass distribution can alter an asteroid's future trajectory. In simple terms, Earth will give 2026 JH2 a hard shove. That shove will change its orbit around the Sun. Not by much, maybe a few degrees, maybe a few thousand kilometers on its next pass. But enough that astronomers will have to recalculate everything. And enough that, for about 45 minutes, the question will hang in the air. What if the calculations are wrong? As of today, May 16th, 2026, the asteroid has not yet arrived. We are watching. We are waiting. The telescopes are tracking. And in just 2 days, we will know exactly how close this basketball court-sized rock will come. The margin of error is shrinking by the hour. But until May 18th at 21:23 Universal Time Coordinated, no one can say for certain. Here is the part that no one wants to admit. 2026 JH2 was not announced to the public until May 15th, 2026. 3 days after discovery. Only 3 days before closest approach. That is not a failure of science. It is a feature of the system. The International Asteroid Warning Network, or IAWN, has strict protocols. They do not issue public alerts unless an object has at least a 1% chance of impact. For 2026 JH2, the calculated impact probability was 0.0000. But here is the uncomfortable truth. Probability is only as good as the data. And for 10 days, the data was incomplete. The asteroid was small. It was moving fast. Its reflectivity was unknown. Early models gave a margin of error in distance of plus or minus 15,000 kilometers. 15,000 kilometers is nothing in space. But it is also the difference between a harmless flyby and an impact over, say, the Atlantic Ocean. Imagine that margin of error had shifted the other way. Imagine that instead of 90,000 kilometers, the closest approach had been 75,000. Still safe. Still no impact. Now imagine 60,000. 45,000, 30,000. At 30,000 kilometers, an asteroid enters the orbital zone of very low Earth orbit satellites. At 20,000 kilometers, atmospheric drag becomes significant. At 10,000 kilometers, you are inside the ionosphere. And at 0 kilometers, you have a crater. 4 or 5 days, from May 10th to May 15th, the world's asteroid tracking community watched those error bars shrink. They watched in private chat rooms, in encrypted emails, in phone calls between observatories. And they did not tell the public. Because the rules said, do not cry wolf. Except this time, the wolf was real. It just missed. But let's play the tape forward. What if 2026 JH2 had hit? First, it would have entered the atmosphere at approximately 17 kilometers per second. At that speed, the air in front of the asteroid doesn't have time to move out of the way. It compresses. It heats. It turns into plasma. At about 50 kilometers above the surface, the asteroid would have begun to fragment. Pieces the size of cars. Pieces the size of houses. Most of them would have burned up completely. But not all. The Chelyabinsk event released about 500 kilotons of energy. That is roughly 30 times the Hiroshima bomb. 2026 JH2 was larger. Possibly twice as massive. An airburst of that size would have released energy equivalent to 1 to 2 megatons of TNT. That is a small nuclear weapon. If it exploded over a city, the shockwave would level buildings for kilometers. If it exploded over water, it would generate a localized tsunami. If it exploded at night, the fireball would outshine the sun for 100 miles. This is not speculation. This is physics. And yet, even with all of that destructive potential, 2026 JH2 was still considered a small asteroid. Because the universe has much worse things in storage. There are asteroids large enough to end civilization. There are comets that could boil the oceans. And we are only tracking about 40% of the near-Earth objects larger than 140 meters. For objects smaller than that, like 2026 JH2, our tracking coverage drops to under 10%. That means for every asteroid we see coming, 9 are sneaking past us in the dark. So what changes after 2026 JH2? The answer is already in motion. NASA's Surveyor mission is scheduled to launch in the late 2020s. It is a space-based infrared telescope designed specifically to find dark asteroids. Unlike ground observatories, Surveyor can look toward the sun. It can see the ones that hide in the glare. The European Space Agency is building the Neomir satellite for the same purpose. And then there is the DART mission, already tested, already successful. DART proved that we can hit an asteroid and change its orbit. That is no longer science fiction. That is a capability. But here is the catch. DART requires years of advance warning. You cannot launch a kinetic impactor 10 days before impact. You need months, ideally years. That means discovery is still the most important step. We have to find them before they find us. And right now, we are not moving fast enough. The 2026 JH2 close approach was a wake-up call disguised as a non-event. Because next time, the margin of error might go the other way. Next time, the asteroid might be discovered not 10 days before, but 10 hours before. Next time, there might be no basketball court. Next time, there might be a football stadium, a city block, a mountain. And the only question will be, did we prepare? On May 19th, 2026, the world woke up and most people had no idea what had just happened. The news headlines were about politics, sports, entertainment. Not about the rock that had passed closer than some of our satellites. Not about the 45 minutes when astronomers held their breath. That is the nature of near misses. They leave no scars. They leave no debris. They leave only data and a quiet kind of dread. 2026 JH2 is still out there. It is still orbiting the sun, and it will come back. Not in our lifetimes, perhaps, but eventually. And when it returns, or when another like it appears, we will have a choice. We can continue with a system that discovers most asteroids after they have already passed. Or we can build something better. More telescopes, more satellites, more warning. Because the universe does not send warnings. It sends rocks. And the only defense is to see them before they see us. This is not fear-mongering. This is arithmetic. There are hundreds of thousands of near-Earth objects we have not found. One of them has our name on it. We just don't know which one. Or when. But on May 18th, 2026, we got a reminder. A basketball court of solid rock, sailing past at 15 kilometers per second. Close enough to touch. Far enough to survive. Next time, we might not be so lucky. If you want to track real-time asteroid data, the links are in the description. Follow the Minor Planet Center. Follow NASA's Center for Near-Earth Object Studies. Because the more people watching, the harder it is for the next one to sneak up on us. Subscribe if you want more stories about the things that live in the dark. And remember, space is not empty. It's just patient.